In this video, I'm going to talk about horizontal projectiles. So it's basically taking something and you throw it horizontally, right? And you're going to describe its motion, right? So initially, it's just going this way, and you're probably expecting it to follow a path like that, okay? And we're going to try to describe this path with the math. So we're going to see what kind of equation we get out of that. Now, in here we have two-dimensional motion. So we have to talk about what's happening horizontally and what's happening vertically. So I'm going to write in the x direction, we're going to see what's happening, and in the y direction, we'll see what's happening. Okay? And they're independent of each other. Now, horizontally, when you throw it, if there is no air resistance, your speed or your velocity should stay constant. So you should end up with a constant velocity in the x direction. And the reason for that is because there are no forces acting on it in the x direction, so there is no reason for it to change its velocity. Okay, so in the x direction, I'm just going to go VO equals delta x over time. And that's it. There's only one equation that we need to deal with here. Now, the delta x is basically how far you're traveling horizontally from your starting point. So if you want to find how far you are after 1 second, you just plug in 1 second here, you plug in whatever speed you're throwing with, and you can figure out how far out you are. Okay. Vertically is a different story. Vertically, you have a force acting on your downwards, so your velocity will change. So you're not going to have a uniform motion. Okay, so in that case, we're going to have to say, well, the acceleration is just negative 10 meters per second squared, okay? And delta y is VOY in the y direction, t plus 1/2 gt squared. Basically, the acceleration is g, okay? Now, initially, when you throw it horizontally, it did not give it any speed, up or down. So this term here is 0, okay? So this should be, basically, it's going to end up being negative 5t squared. So if you want to figure out like how much you dropped after 1 second, you just plug in 1 second there, and you're going to see that you dropped 5 meters after 1 second. This is just like free fall, basically. So this thing is actually free falling, and it's moving forward at the same time. Okay. The other equation is v in the y direction is v0 y plus gt. Well, this one is gone, 0. Okay. The other one is Vy squared is V0 y squared plus 2g delta y. It's gone, it's 0. And the last one I'm going to do is the one that does not have acceleration in it. So delta y is V0 y plus Vy over 2 times t, and this is gone. And I hope you understand why the V0y is not there, because when you throw it horizontally, you did not give it anything up or down initially. It was straight up. Okay? So that's pretty much horizontal projectiles. And there is more to it, but which we'll do in class. So let's describe the trajectory of this projectile. A projectile, by the way, is just any object that's in the air under the influence of gravity alone. Nothing else is acting on it, no air resistance. So we're going to describe mathematically what is the equation of this trajectory here. Now, if you notice, the only thing that's common between these two sides is time. Okay? So now I'm going to take this equation and this equation, and I'm going to play with them. So I'm going to say delta y is equal to 1/2 g t squared. And then I'm going to take the t from this equation, which is delta x over VO, and I'm going to plug it in here. So it's going to be 1/2 g delta x squared. I'm going to break it up over V0 squared. So I'm going to rewrite it nicely here. So it's going to be g over 2 V0 squared. This is not in your formula sheet, and do not write it on the formula sheet, because you can do all the math just with the equations you have on that side. Delta x squared. Now, if you look at this equation here, that's the equation of a parabola. Okay? So mathematically, this is represented with a parabola if you get rid of the time. And that's horizontal projectiles. See you later.